Here we go. Where we picked up after last week's episode, we're going to go to a question from my friend Max Wild, who's always been a stalwart supporter, another pilot as well. And Max asks, what can be done about all the space junk orbiting the Earth? And I have to tell you, Max, I don't really know. There have been a couple proposals for the space junk, and the main reason I wanted to take the question was what happens if we don't clean up the space junk. But in terms of what you could do to clean it up, there's been some discussion about the smaller pieces of space junk being vaporized by ground-based lasers, basically either vaporizing them or slowing them down enough so that they deorbit. That's one potential, is to put a pretty decent-sized honkin' energy weapon on the surface of the Earth and vaporize the smaller ones. The smaller ones are virtually as dangerous as the larger ones. To be honest with you, you get hit by a BB moving, at some significant section of 15,000 miles per hour, and you get what you get in the movie Gravity. It's just like disintegrates whatever it hits. So collisions are bad. Most of the space junk is stuff that just happened flying missions. Most people don't know this, but most of the stuff, or almost half of the stuff in orbit, is the booster. You've got to get that satellite into an orbit, which means you got to have a launch that gets it up to a certain orbital altitude, and then it's got to coast about halfway around the world, and then it has to fire again to bring the perigee up, which normally would be on the ground, the perihelion or periapsis, whatever you want to call it. So you've got to keep that booster in space, and when the thing has finished the burn that puts the satellite into orbit, the satellite separates from the booster, but the boosters are up there. There is, by the way, an app that I thought might be a good chance to talk about this super fast. I cannot recommend this highly enough. I think I might have talked about it once on Stratosphere Lounge a long time ago. I'll show you what it looks like real quick. It's called GoSatWatch, GoSatWatch. And they also make one called Go Skywatch, which is a great little pocket planetarium, but we'll get to that later. So here is GoSatWatch. And it gives you the option of looking at the night sky and showing you what's above the horizon. Most of the stuff you see there is below the horizon. But you can also do something with this where you basically look at the world. And here's the world on GoSatWatch. I know this is going to be kind of hard to see. But you can see what's in orbit and you can see what's overhead. But most of these things are boosters. And so the great thing about this app, by the way, is not to see how many boosters there are, but the great thing about GoSatWatch is if you give it your location, you can take it outside on any given night and it will show you where all the satellites are. And I've been out in the desert in Arizona with this at sunrise and sunset, and I've seen, 30 maybe in an evening, 20. Some of those are pretty faint. Shows you where the space station is, and the space station is the brightest thing in the sky. Space station, I think, is brighter than Venus. The space station is golden from the solar panels. The space station is a sight to see. Anyway, you can see it with GoSatWatch. So the smaller ones you might be able to vaporize, Max, and then there's been some actual talk about missions to actually have satellites that move, that can change your orbit and have little nets, literally just scoop it up and deorbit it. All you have to do is slow it down. None of this stuff up there really is so big to be a problem. There are probably a couple of boosters up there, but boosters are basically just hollow. The thin, the skin on an Atlas rocket that John Glenn rode into orbit on Friendship 7, 62, I guess it was. The skin of the Atlas rocket is thinner than a dime, so it gets its strength through pressurization and some stringers. But all you have to do is slow the stuff down enough and it burns up in the Earth's atmosphere. But the reason I wanted to take the question is because we are in real danger of something happening. And if this happens, it's a bad deal. You may have other names, but I've heard of it as I've heard it called the Cascade. And here's what the Cascade basically says: if we have a lot of stuff in low Earth orbit, a lot of stuff, a lot of junk, and a lot of useful satellites, a lot of dead satellites, and they're all still up there. And basically, the Cascade theory is this: we've had a couple satellites collide. I'm aware of one case where an American satellite collided with a Russian satellite. It just happened. I mean, stuff's been moving around up there forever, and finally it did happen. It's a pretty hard thing to do when you think about it in 4 dimensions, 3 dimensions plus time. Satellites are not very big, but sooner or later, two of them hit each other. and they created a massive amount of debris. We've also done a test of an anti-satellite weapon on a satellite, and our test was on a satellite that was set to re-enter the Earth's atmosphere, so it was really no harm. But the Chinese destroyed a satellite that was well established in orbit, put a lot of debris up there. So here's the cascade problem. The cascade problem says if one of these things hits again in low Earth orbit, or one is destroyed, or one just explodes, or whatever, or a little piece of debris hits an existing satellite, that little piece of debris hitting an existing satellite makes a lot of debris, a lot, like a shotgun blast. And that shotgun blast continues in orbit, and since it's so much more of it, then it hits something else, and that creates an even bigger cloud of debris, which means it hits even more, which creates even bigger clouds of debris. And the next thing you know, low Earth orbit is not survivable. It's not obtainable. We can't get there. That would be a catastrophe. It is so much more difficult to get into a highly inclined orbit. And even if you're in a highly inclined orbit, sooner or later you're going to have to go through that belt of stuff. It would be the end of our ability to get into space for hundreds of years. So we need to be thinking about that. We need to be thinking about that. It's hard for people to believe or understand, but every now and then people in the International Space Station get a command from the ground where NORAD has determined that we want to move the station just a little bit because there's a bolt or something the size of a hammer or something that they're tracking on radar, individual bolts that might come a little bit too close. So they move the station because they know that 6 days from now this bolt is going to get a little closer than we would like. It's absolutely amazing when you think about it. But if this cascade thing happens, we're out of space. It's bad. That's exactly, as I say, what happened in the movie Gravity. And the movie had a couple problems. I thought the biggest problem was the story problem. I didn't believe there was a story, and I didn't care about the person. But other than that, there were people quibbled about one or two of the physics things, and one thing was absolutely ridiculous. But by and large, it wasn't too bad. And the thing I like most about Gravity was when you saw the debris coming by, you saw how fast it was moving. It wasn't like, oh, here comes a tumbling piece of debris, boom, boom, bounces off the spaceship hull. It's 17,000 miles an hour. So anyway, the debris thing is a serious problem, Max, and here's what I'm afraid of. I'm afraid it's going to be the kind of thing that people are only going to take seriously after it happens, and then you can't do anything about it. So that's a problem.